Okay, so I hope you didn't struggle too much with this. I hope you at least were able to do, a few of the problems. And then if you're looking here though for extra support, I totally get it. This is very new and different. Okay, so for the first one, 2u, I just wanted you to use the u that's above and try to get it kind of at the same angle, and it looks like it needs to be twice as long. So that would be my answer for 2u. I'm just comparing my blue to what I see here, making it twice as long. Number 2, negative 1/2 v. I'm going to cut the length of this in half, okay? But then I'm also going to flip the arrowhead because there's that negative that's on it, so it needs to go in the opposite direction as well. And then the last one, u plus w. I'm going to use the triangle method. So I'm going to redraw w as best I can by looking above. It may be a little longer. And then I'm going to take u and connect it. Now I need to connect u not here, but I'm going to connect it here, because for the triangle method, you want to connect them head to tail. And then the resultant, or the answer, is the final vector where you connect the triangle. So this red vector is the answer, and we need an arrowhead on it. It needs to go up here. So that would be my answer for this problem, is the red vector. All right. Now we get to go on to a coordinate plane, okay? So use the given coordinates for numbers 4 to 6. Initial point, negative 3, 4. I'm going to go ahead and draw that. Negative 3, 4, so there's A. Terminal point, 0, 5. Okay, so here we have this little baby vector right here. Number 4 wants us to determine the length of AB. So this is the magnitude, like those absolute value bars I showed you. I'm going to go ahead and shift this to the origin first, and that's going to help me with numbers 4 and 5 and 6. So that's just my preference. If you didn't do that, that's fine, but that's what I'm going to do. So if I move this to the origin, then it looks like the terminal point is 1, 2, 3 away and up 1. Okay, so that's just me looking at my grid. This was an easy one to count, so I just counted it. And that actually is the component form. It's the point 3, 1, and you just put it in the chevrons now, okay? Or you could have done head minus tail, which I told you earlier. So if you take this one and you subtract that one, you would get the same thing. All right, now to determine the length. Well, I'm just going to do like Pythagorean theorem on it. That is 3 long across the bottom, so 3 squared, plus that's 1 squared across the top. So I'm just imagining a right triangle, and I'm going to solve. So that would be a 10, right? So C is the square root of 10. Now, I'm going to leave it as the square root of 10. If you turned it into a decimal, that's perfectly fine. What would that be? 3 point something? Square root of 10. 3.16. Okay, I don't know what your teacher's going to want. I always wanted the exact answer because it's exact. Now determine the direction of AB. So the direction is the angle. So it's still here, so I need that little angle. So if I need the angle, then I know the sides of the triangle. Oops, I drew that just a little too tall. Sorry, it's really down there. I need the sides of the triangle. That was 1 and that's 3. So I'm going to do like I did in the notes and just do that the tangent is 1/3. That's the opposite over the adjacent. And now I'm going to do a second tangent of 1/3. Second tan of 1/3. I'm getting 18.4 degrees. And I'm going to go ahead and write north of east because that's what quadrant I'm in, and that's how I can express that angle. All right, cool. Now we move on. I don't know how that went for you, but hopefully that went okay. Just a lot of right triangle stuff. The next is use the given vectors for 7 through 10. Okay, so now they've already given me terminal component form, which means that the tail is already at the origin. So sketch 1/2 W. Well, I'm just going to multiply this by 1/2, and that's going to turn into the point -1, -7/2. So just multiply both x and y. So -1 and then -7/2, that would be -3.5. So right there. Okay, so there's me sketching what they want me to sketch. Number 8, determine u plus 2x, okay? Well, I could draw it, or I could just do whatever it wants me to do here. Now, there is no u and there is no x, so this is a very interesting problem. Okay, I'm changing this. I don't know what happened here. How about this? How about v plus 2w? I don't know where those u and x came from. It's probably some kind of autocorrect madness, but that's okay. Okay, so what we're going to do is just do the points. I'm just going to do 3, negative 5, plus 2 times this other one. And so when you bring this down, I'm just, PEMDAS, right? 2 times both of those, so just distribute that 2. And now add them together, x with x and y with y. So the answer to this is going to be negative 1 comma negative 19. Okay, great. So hopefully you paused and tried it. If not, you're seeing me do it. You really are just doing arithmetic there. Number 9, find the magnitude of v. So to find the magnitude of v, if it helps you to draw it, that's fine. V is at 3, negative 5. So maybe it'll help because then you can see, oh yeah, that's 3 and that's negative 5. So you could do Pythagorean theorem. We're just trying to find out how long it is. So 3 squared plus 5 squared equals c squared. So that would be 9 plus 25. So I'm getting the square root of 34. Okay? And then find the direction of w. Okay? Well, w is at negative 2, negative 7. So if it helps to draw it, draw it. Okay, so that's the green one. We're looking for the angle. Now the angle and the direction we always want to do with the x-axis. And if I didn't mention that, you might want to make a big deal of it now. You always want to go with the x-axis here to be consistent with everybody. And I'm going to draw a triangle then up to the x-axis. And by doing that, then I can label that's 2 and that's 7, and I can do that same tangent thing that I did before. So the tangent of that angle is going to be the 7 over 2, the y over the x. And this calculator is giving me, what is this, 7 over 2, I'm getting 74 degrees. So theta is 74 degrees. Now you got to be careful because you're in quadrant 3, so it's 74 degrees of what? Well, it looks like it's 74 south of west. That would be how you could denote that. And if you need help with that, just ask me in tutorials or something how to do the direction part. It's just looking at what quadrant you're in. You kind of start in the back. I went down from the left. So down is south, the left is west. And now the fun one. Okay. So, yeah, I did that on purpose. If you didn't catch that, ignore the grammatical errors. Okay, so we've got a plane. And, okay, so the plane is going 410 miles per hour at 50 degrees south of east. So the east is here. I need to go south of that 50 degrees. That's a 50, and that is 410. We encounter a wind at 15 degrees north of east, so the wind is 15 north of east, so just a little angle, and it's just a baby vector. It's only going 30 miles an hour, and that is 15. Okay, so here's my picture. Number 12, find the components of the plane and the wind. Okay, so for the plane, I'm going to do the x and the y by doing that formula I showed you guys earlier. So the x, so it's the magnitude times the cosine of the angle, and the magnitude times the sine of the angle, and then just pay attention to what quadrant you're in, okay? So I'm in quadrant 4, which means you guys better have made your y negative after you type it in. The calculator's not going to understand to make it negative for you. You have to think that part through. So I'm getting 263.54. And by the way, if you're not getting the same stuff I'm getting, make sure you're in degrees. Like if you're typing this in and you're like, how is she getting that? I'm in degree mode, that's how. 314.08. Okay, so I just kind of went out a little further. All right, and then my wind. Same thing. Now, if you now are realizing how to do this and you're like, oh, okay, hit pause and try the wind again on your own and then hit play again and see if you did it right. So for the wind, magnitude, cosine, magnitude, sine, and that's what I'm typing in. It's in the first quadrant, so everybody's positive, so I don't have to worry about my signs. Okay, I'm getting 28.98, and then for this one, I'm getting 7.76. Okay, great. So those are my plane and wind components. For the next one, find the actual components and the new speed and direction. Okay, so now I just need to add them together. That's it. Plane plus wind is actual components. So if I add them together, I'm going to get 263.54 plus 28.98. Okay, I am getting 292.52. And my y, I'm going to have a negative 314.08 plus 7.76. So I'm getting a negative 306.32, okay? And that is my new vector. That's where it's at. And if you want to sketch it in here, you can. It should be somewhere in between these two, but it's still going to be in quadrant 4, it looks like, okay? Now for the new speed and direction. The new speed is magnitude, right? Speed is magnitude. So I need to do the length of this. Well, the length, this is my x, this is my y. So if I drew a triangle out of it, I'm just looking for the hypotenuse. So I'm going to do 292.52 squared plus 306.32 squared, and that's my new magnitude, right? So here goes nothing, 292.52 squared plus 306.32 squared. Okay, and then I'm going to square root that. I'm not going to do an exact answer here. I mean, if everybody else is a decimal, then leave this as a decimal too. Okay, this is my new speed. So here's my new miles per hour. Now let's compare this to the original. Did the plane speed up or slow down? The plane was 410 and now it's 423, so it's sped up. So I know it didn't ask me, but this is a tailwind, just something to think through. Now the direction is the angle. So if we had drawn the picture of where this vector is and drawn a triangle out of it, we could do that same tangent of the y over the x, just like I did throughout the whole rest of this worksheet, and absolute value of that. Okay, so I could have done the tangent of the y over the x, and that's going to get me my angle. So tan inverse of 306.32 divided by 292.52, and that's getting me 46.32 degrees. Okay, so where would I be located? Well, if I'm in this quadrant, it's close to that red one. So I would have 46.32 degrees, and it would be south of east. So notice the plane was at 50 degrees, it's now at 46. So this little wind, it didn't knock it off course very much. It just kind of knocked it about 3-4 degrees off course. But, you know, it sped it up at the same time. So that's kind of what you learned about that wind hitting that plane. Alright, hopefully that's at least an intro and some of that makes sense. Keep this video. When you're doing this in class, it may be like 2 months from now. I'm not sure exactly when you'll do it, but in physics and in pre-cal, keep the videos so that you can come back and grab these formulas if the way that you're being taught is weird to you. They're probably going to teach it this way, especially in pre-cal, but in physics sometimes they do things a little different, and this way will work, so yay. Alright guys, hope it went okay for you, and we will see you next week.